Hi students, this is Sivakumar, 12th standard Business Mathematics and Statistics, chapter number 5, continuation of exercise 5.2. In method of interpolation, already have completed the graphical method. Now we can go for that algebraic method. So what is given? Newton's Grigori forward interpolation formula or Newton's forward interpolation formula for equal intervals. Okay, here let y that is equal to f of x denote a polynomial of degree n which takes n plus 1 values, let them be y0, y1, y2, etc. up to yn, corresponding to the values of x0, x1, x2 up to xn respectively. Look at that example. Here's example number 13. You are given that 1891, 1901, etc. These are all x0, x1, x2, x3 and x4. This one is y0, y1, y2, y3 and y4. Okay. The values of x, that is x0, x1, x2, x3 up to xn are at equal distance. Equal distances means equidistance means equal distances. Look at that. Here the same example 1891, 1901. So difference 10 years difference between these two, 10 years difference between these two, 10 years difference between these two, also 10 years. So equal interval. So that is x1, we have to calculate x1 that is equal to x0 plus h. Like that x2, that is x0 plus 2h, it is going on. Okay, finally you have to calculate xn that is equal to x0 plus nh. Then the value of f of x at x equal to x0 plus nh is given by the formula f of x0 plus nh, that is equal to f of x0 plus n by 1 factorial into delta of f of x0 plus n into n minus 1 by 2 factorial into delta square of f of x0 plus n into n minus 1 into n minus 2 divided by 3 factorial into delta cube of f of x0 plus etc. It is going on. Or else we can represent the same formula as y of x that is equal to x0 plus nh, that is equal to this f of x0 can be replaced by y0. N by 1 factorial, right, as it is. Delta of f of x0 can be written as del of y0. So wherever f of x0 comes, that can be replaced by y0. Same formula only. Okay. What is the formula for n? For finding the value of n, you have to make use of this formula, x minus x0 divided by h. This is the Newton's Grigori forward interpolation formula. Particularly this note, after writing this formula, you write this note. Newton's forward interpolation formula used when the value of y is required near the beginning of the table. Near the beginning of the table, you can see. Listen to this example. Example 5.13. Same example only I am considering. You are asked to find out that estimate the population for the year 1905. 1905 here only, in between 1901 and 1911. So here what is given? Since the value of y, this is the value of y required near the beginning of the table. So this is the x value. Actually 1905 is x value. You are asked to find out y value. Y value will be here in between these two only. So what is given? Since the value of y is required near the beginning of the table, not from the end of the table, from the beginning of the table, it is nearer. We use the Newton's forward interpolation formula. Okay. Next, Newton's Grigori backward interpolation formula. Newton's forward interpolation formula cannot be used when the value of y is required near the end of the table. For this, we use another formula called Newton's Grigori backward interpolation formula. Then the value of f of x at x equal to x n plus nh is given by the formula. Here x naught, you are given x naught plus h. Here it is xn equal to x naught plus nh. Okay, here x equal to xn plus nh. Remember, here f of xn plus nh equal to f of xn plus n by 1 factorial. This is nebula. Here delta, this one is nebula. F of xn plus n into n plus 1 by 2 factorial into delta, nebula square of f of xn plus n into n plus 1 into n plus 2 divided by 3 factorial into delta cube of f of xn plus etc. Or else you can represent y of x that is equal to xn plus nh, that is equal to wherever f of xn comes, that should be replaced by yn, the same formula. So after writing this formula, we have to write this note: Newton's backward interpolation formula is used when the value of y is required near the end of the table. So for your reference, I take this example 19. Calculate the value of y when x equal to 7.5 from the table. These are all x values. Start with x0, x1, x2, x3, x4, x5, x6 and x7. From here to there, each and every one is y0, y1, y2, y3, y4, y5, y6 and y7. You are asked to find out, since the required value x value is 7.5, the required value between 7 and 8 here will be the required value between 343 and 512, correct, is at the end of the table. Apply backward interpolation formula. So which formula to be applied? Grigori Newton's backward interpolation formula. Okay, this formula to be applied. Okay, in the next video I'll be teaching that exercise 5.2 third problem. Thank you, children.